Hello my dear children, once again welcome to our physics class. Hope you all are fine over there. Children, we had discussed about reflection, laws of reflection and also its applications, especially in the case of mirrors, in our previous sessions. Today we are going to discuss another major concept of this chapter, that is refraction. Children, do you think that light will always reflect? Suppose light happens to travel from one medium to a different medium. In that case, does light continues its same straight line? You had already studied in your lower classes that light always travels in straight line. Yeah, it's true. Light always travels in straight line. But it's true only if light passes through a single medium. But what if two different medias are present? Still, light can continue its same straight line path when it happens to pass through two different media. Children, when light passes from one medium to another medium, some portion of the light is reflected to the first medium and some other portion of the light passes or crosses the boundary between two media and enters into the second medium. Okay, in doing so, there is a change or there is a deviation in the path of the light. So the light will bend at the boundary between two media. And this bending of light, when light passes from one medium to different medium, is known as refraction. And we are going to discuss about refraction through more interesting examples. Children, you just imagine you are riding a bicycle and you are going through a straight road. Suddenly you entered a beach side and you changed your bicycle, you changed the direction of the bicycle from road to the beach side. What happens? Will you be able to follow the same straight line path? No. Your path will deviate. There is a change in the direction or there is a change in the path of your bicycle. You won't be able to follow the same straight line path when you suddenly enter from the road to the beach side. Just like that, when light passes from one medium to another medium, light won't be able to continue its straight line path. There will be a bending at the boundary. Okay, so this phenomenon is known as refraction. Here you can see a pencil is dipped in a glass which is partially filled with water. And this is the boundary between water and air, isn't it? Above the boundary, air is present, and below the boundary, water is present. So this is the boundary between two different media, air and water. And the pencil appears to be broken at the boundary between two different media. But if you take this pencil out of the water, you will be able to identify the pencil is not actually broken. It just appears to be broken. This is because of refraction, and this appears to be broken just because of the bending of light when it passes from water to air. Okay, again you can see here another phenomenon, that is lemon, which is placed inside the glass filled with water, appears to be thicker than its actual size. Lemon appears to be bigger than its actual size. But when you take this lemon out of the glass, you will be able to identify it is not bigger, actually it just appears to be bigger. Okay, then here this is another important phenomena, and we make use of this phenomena in fishing. Here you can see this is the actual position of the fish and this is the apparent position of the fish. Okay, that means the things inside the pond appears to be slightly above than its actual position. Here, see, this is the actual position of the fish, but the fish appears to be slightly higher than its actual position for this observer. And this is also due to the bending of light at the boundary. So this is the boundary between air and water, and at this boundary there is a bending of light. Okay, here you can see that, see, this is the actual position of the fish, and from here the light ray will reach the boundary, and at the boundary it will bend, isn't it? At the boundary it will bend and it will move like this. But our sight of our line of observation is along the straight line, isn't it? Our line of observation is along the straight line. So he feels that light is coming from this point, from here. Here you can see one thing, rarer medium and a denser medium. A light ray can travel from rarer to denser medium. Light ray can also travel from denser to rarer medium. So what happens in both the cases? Obviously, in both the cases, light ray will bend. And also you may think about rarer and denser medium. I know that. So don't worry about rarer and denser medium. We will discuss more about these concepts towards the end of this chapter, or towards the end of the session itself. Not towards the end of this chapter, towards the end of the session. So when light ray passes from rarer to denser medium, the light ray bends towards the normal. Here you can see the normal. Normal is an imaginary line which is drawn perpendicular to the surface or to the boundary. Okay, so here when light ray passes from rarer to denser medium, what happens? This blue color is the light ray, and this light ray, see, from the first medium, it must continue its straight line path, which is shown by this pink dotted lines. But due to the presence of the second medium, it cannot continue its straight line path. At the boundary, it bends, and it bends towards the normal, isn't it? So whenever light ray passes from a rarer to denser medium, it bends towards the normal. Just look at the second figure here. Here light ray passes from denser to rarer medium. So here this blue color represents the light ray, and it must continue its straight line path. It is supposed to be to follow this straight line path shown by this pink dotted lines, but due to the presence of the second medium, it bends and it moves like this, which is shown here, isn't it? So here bending occurs away from the normal, isn't it? So whenever light ray passes from denser to rarer medium, it bends away from the normal. So this is the most important concept that you must remember related to refraction. Whenever light ray passes from rarer to denser medium, it bends towards the normal. And whenever light ray passes from denser to rarer medium, it bends away from the normal. Okay. Now, next we are going to discuss an important concept, that is refraction through glass slab, and you must draw and study this figure because you can expect this question for your board exams. This is one of our diagrams from light chapter. Okay, so this diagram is very important. So here you can see this is a rectangular glass slab, PQRS. This blue color slab is a rectangular glass slab, and here is air, this is glass, this is air. So two different media are present here, and you can see this ray. This ray is the incident ray because this ray is incident on this glass slab on the surface PQ, and here light ray is passing from air to glass, isn't it? Light ray is passing from air to glass, and this is the normal. So here you can see one angle, and this is the angle between incident ray and normal, that is angle of incidence. And this is the boundary between air and glass, isn't it? This is the boundary between air and glass. And air is a rarer medium, glass is a denser medium. Okay, we will study about rarer and denser medium. So now you must remember this concept. Air is a rarer medium, glass is a denser medium. So what happens? Yes, light ray will bend because air and glass are two different medium. They have different densities. So light ray will bend. So does it bend towards the normal or away from the normal? So just now we had discussed, whenever a light ray passes from rarer to denser medium, it will bend towards the normal. So here this light ray bends towards the normal. See, this is the refracted light ray and it bends towards the normal. And this is another angle, and this is the angle between normal and the refracted ray, which is angle of refraction. Okay, and here once it bends, it will continue the same straight line path. See, here it is a straight line because it is traveling through a single medium glass, and this is the next boundary, another boundary, and here the boundary is between glass and air. So here the light ray is passing from glass to air. That is, glass is a denser medium, air is a rarer medium. So light ray is passing from denser medium to rarer medium. So again light ray will bend, but here light ray will bend away from the normal. Just now we discussed that. Light ray will bend away from the normal at this boundary, because at this boundary light ray is passing from denser to rarer medium. So here you can see this light is bending away from the normal. And here you can see an angle E. E means it is the emergent angle between emergent ray and the normal. Okay, so E is the angle between emergent ray and normal, which is known as angle of emergence. But in your NCERT book, this angle has been represented as I2. That is angle of incidence for the second boundary, and this emergent angle has been represented as R2, which is the second angle of refraction. And this angle is denoted by I1, and this angle is denoted by R1, which is the first set of angle of incidence and angle of refraction, and this forms the second set of I2, and R2 forms the second set of angle of incidence and angle of refraction for the second boundary. Okay, so better you follow the textbook notations. Okay, so this is the refraction through glass slab, and in order to understand the refraction phenomena occurring through glass slab, you must know the concept. Whenever light passes from rarer to denser medium, it bends towards the normal, and whenever light passes from denser to rarer medium, it bends away from the normal. And here you can find one more, or you can study one more concept, that is, see, here this is the incident ray, and this incident ray is supposed to follow this path, supposed to move through this straight line path, isn't it? But due to the presence of this glass slab, it has been deviated from its normal path, or from its original path, and it has been emerged like this. So this is the original path. This dotted lines represents the original path of incident light, and this ray represents the emergent path of the incident light. So there is a shift of the incident ray, or there is a shift of emergent ray from the incident ray position, and this shift is known as lateral shift. Okay, this shift is known as lateral shift, and this lateral shift is denoted by this symbol delta. This symbol is delta, and this is the lateral shift. So while drawing this refraction through glass slab, you must represent this lateral shift. It's there in your NCERT textbook. So please go through the figure in your NCERT textbook and try to identify the concept of lateral shift. Okay, so what is lateral shift? It is the shift of emergent ray from the incident ray position. Okay. Now, we had studied laws of reflection. Similarly, we have laws of refraction. And the first law of refraction is similar to first law of reflection. Listen, the incident ray, refracted ray, and the normal to the interface of two media at the point of incidence all lie on the same plane. Okay, in reflection we had studied the incident ray, the reflected ray. isn't it? Here instead of reflected ray we have, here instead of reflected ray we have refracted ray. So the incident ray, refracted ray and the normal at the point of incidence all lie on the same plane. Okay, and what is the second law? Second law is different from that in the reflection. Second law of refraction is the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. And this second law of refraction is also known as Snell's law of refraction. Snell is the name of a scientist. So, second law of refraction is very, very important. Second law of refraction states that the ratio of sine of angle of incidence. Sine of angle of incidence means we can write like this, sine I, that is sine of angle of incidence. And the ratio, so sine I by ratio of sine of angle of incidence and sine of angle of refraction. So there is a ratio between angle of incidence and angle of refraction. So sine I by sine R forms the ratio of sine of angle of incidence to the sine of angle of refraction, and that ratio is a constant. Okay, that ratio is a constant. So this is the mathematical expression for the second law of refraction, and the second law of refraction is known as Snell's law of refraction. Okay, so what is Snell's law? The ratio of sine of angle of incidence to the sine of angle of refraction is a constant, and this is Snell's law. And what is the mathematical expression for Snell's law? Sin I by sin R equal to a constant. From the mathematical expression itself you can easily state the law. So just remember the mathematical expression. You can easily frame the law from the mathematical expression. Okay, so I told you sin I by sin R is a constant. And what is this constant? This constant is represented by n, 2, 1. And this n means nothing. N is refractive index. N is refractive index. It's a new physical quantity. Okay, refractive index. So the ratio of sine of angle of incidence to the sine of angle of refraction is a constant, and that constant is known as refractive index. And here I have written n21. n21 means refractive index of second medium with respect to first medium. n21 means refractive index of second medium with respect to first medium. Similarly, we can also write n12. So what do you mean by n12? n12 means refractive index of first medium with respect to second medium. Okay, n12 is refractive index of first medium with respect to second medium. And we can write like this, n21 is n2 by n1. n2 refractive index of second medium, n1 refractive index of first medium. And similarly we can write n12 as n1 by n2, where n1 is refractive index of first medium and n2 is refractive index of second medium. Okay, and when do we use n21? When do we use n12? See, here in this figure you can see one thing. Light ray passes from a medium having refractive index n1 to a second medium having refractive index n2. So here bending occurs as the boundary, and the bending occurs in the second medium, isn't it? The light ray bends and enters into the second medium. So in which medium that bending has occurred, we are finding out the refractive index of that medium. So here bending has occurred in the second medium. So we are getting, or we obtain, the refractive index of second medium with respect to first medium. Okay, but if light ray has gone like this, just look at the arrow mark. Here what happens? The light ray is passing from second medium having refractive index n2 to the first medium having refractive index n1. So in this case, bending has occurred in the first medium, and we obtain refractive index of first medium with respect to second medium.